Here's a detailed example of how to graph a rational function with asymptotes, intercepts, and inequality intervals. So let's start off with finding the asymptotes. The easier of the ones to find are the vertical, and the vertical ones are found by just letting the bottom, the denominator, equal 0 and find out when that happens. So we're going to do x squared minus 4, set it equal to 0. And to solve this, we need to factor x squared minus 4, which is x minus 2 and x plus 2. And these solutions will give us our vertical asymptotes. So we're going to get vertical asymptotes at x equals negative 2 from the second factor, and x equals positive 2. So these will be the lines that the graph can never ever cross. Vertical asymptotes you can't cross. Alright, the next one would be horizontal. And when you're looking for horizontal asymptotes, it's best to use the limit as x gets really big, because horizontal asymptotes are not specifically at a value, they're a what happens as x gets really, really big. So I'm going to take everything up here and divide by the highest power of x, which happens to be x squared. So I'm going to have 2x squared divided by x squared plus 5x divided by x squared minus 3 divided by x squared. And this is legal because I'm doing it to the top and the bottom. So here we'll have x squared divided by x squared minus 4 divided by x squared. And then reduce each one of the terms. So this becomes a limit as x gets really, really big, positively or negatively, by the way. We're going to get 2 plus 5 over x minus 3 over x squared in the top. And in the bottom, we're going to get 1 minus 4 over x squared. Now, as x gets really, really big, these fractions are going to get infinitesimally small. So basically, these three are not going to contribute a lot of value to this expression as x gets really big. So we're going to assume that these things are getting so close to 0 that they're really not going to affect anything. It's like giving $1 to Donald Trump. He's not going to thank you. Alright, so what we're left with is 2 divided by 1, so our horizontal asymptote is going to be y equals 2. Alright, now the next step I highly suggest you take is find out if the graph does indeed cross this horizontal one. Unlike vertical, horizontal asymptotes can be crossed. These are just what happens to the graph as it goes way, way far away. So let's find out if it actually crosses x equals 2. Or, I'm sorry, y equals 2. I'm just having a bad time with this one. Alright, so if we want to find out if it crosses at y equals 2, all we have to do is let f of x equal 2. So we're going to get 2 equals 2x squared plus 5x minus 3 all over that x squared minus 4. And then solve for x. So multiply both sides by x squared minus 4, and you're going to get 2x squared minus 8 is equal to 2x squared plus 5x minus 3. Nice enough that there's 2x squares on both sides, so those cancel out. And we're down to a linear equation. 5x minus 3 is equal to negative 8. So we'll just move everything away from the x. So add 3 to both sides. We'll get negative 5 is equal to 5x. And finally we find that x is equal to negative 1. So this tells us the coordinate negative 1, 2 is going to be a point on this graph, and it's also the point where it crosses the horizontal asymptote. Second thing it tells us is it never crosses it anywhere else. So this is the only point of intersection between the graph and the line y equals 2. The next part goes back to how we were graphing a lot of other things. We're going to find y-intercepts, and x-intercepts, and that'll give us some more clues about this graph. So if I'm looking for a y-intercept, you're going to let x equals 0. So we're finding f evaluated at 0, and we're going to find that it's going to be, well, that's 0, and that's 0. So all we're left with is negative 3 over negative 4, better known as positive 3/4. So the only time it crosses, well, this better be the only time it crosses the y-axis, since it's a function. We're going to have x is equal to 0 and y is equal to 3/4. And then x-intercepts, we're going to let y equal 0, or f of x equals 0, so we're going to get 0 is equal to 2x squared plus 5x minus 3, all over x squared minus 4. Of course, the first step of solving this equation is to multiply both sides by x squared minus 4. When you multiply this side by x squared minus 4, it just goes away, so we're just left with the quadratic equation, 2x squared plus 5x minus 3 is equal to 0. And all we have to do to solve this equation is factor this. So, factors of 6 that subtract up to 5, which would be 6 and 1. So we'll break this apart into 0 equals 2x squared plus 6x minus 1x. They have to be different signs because it's minus here, and it has to be positive 6 because you need a positive 5 up there, minus 3. But then GCF the first two, which would be 2x. Left behind would be x plus 3. GCF of the second two would be negative 1. Left behind would be x plus 3. And we'd finally get x plus 3 times 2x minus 1. And remember, this whole thing is equal to 0. Alright, and that gives us solutions of negative 3 and positive 1/2. As coordinates, this would be negative 3, 0, and 1/2, 0, as our two x-intercepts. Alright, the last step before I start graphing this will be to find the intervals when this thing is above or below the x-axis, positive or negative. We're going to do it in factored form, so we're going to go back and steal some information. One of the factors at the top is x plus 3 and 2x minus 1. And the factors at the bottom are x plus 2 and x minus 2. And I'm just going to set up a positive inequality, but basically what I'm looking for is just when it's positive and when it's negative. I'm going to have 4 numbers here, smallest one being negative 3, so I'll put that over here. Next one would be negative 2, next one would be positive 1/2, and lastly positive 2 over here. Now I'm just going to do this like a regular inequality, take negative 4. And I'm going to do a lot of this work in my head, so pay attention. This one will be negative, this one will be negative, this one will be negative, this one will be negative. So that's 4 negatives. So on this interval, it must be above the x-axis, positive. Picking a value between negative 3 and negative 2, the best one that I can think of is negative 2.5. So this one here would be positive, this one here would be negative, this one here would be negative, and this one would be negative. So you'd have 3 negatives that'll give us a final solution that happens to be negative. Picking a number between negative 2 and 1/2, that one's easy, 0. So if we let x equal 0, this one's positive, this one's negative, this one's positive, this one's negative. So the final solution will be positive. And I'm going to skip ahead and just kind of jump through the answers. Here I'd pick 1, it would be negative. Here I'd pick something like 3, and it would be positive. They alternate, and the reason for that is each one of these powers is just plain old 1. So nothing fancy is going to happen. So we know for it that it's above, below, and above for these values, negative 3, negative 2, 1/2, and 2. So here I have all my information together, my vertical asymptotes, my horizontal asymptotes and the point it crosses at, my y-intercept and my two x-intercepts. And I've plugged all that into my graph already. My vertical, my horizontal, where it crosses y-intercept and x-intercepts. The last piece is I want to get in these intervals. So I'm going to use a little picture drawing to try to demonstrate this and where they would go. For instance, anything below -3 has to be above the x-axis. So the only place it could go is in here because it cannot cross the horizontal asymptote. From -3 to -2, the only place you can go is below, and here's -3 and there's -2. So the graph would have to be in this portion. And also it would have to approach this horizontal, or vertical asymptote. Between -2 and 1/2, between this and 1/2, which is over here, the graph would have to be above the x-axis. So we're only talking about from here to here, it would have to be above the x-axis. And it has to cross that one point right there. So it wouldn't stop here. Remember, this is crossing it. So we're talking about a graph in this portion of between the asymptote and that point 1/2. Alright, and then lastly, we're going, I'm sorry, not lastly, but between 1/2 and 2, we'd be below again. So here's 1/2 and there's 2. Our graph would be in this little area. And then above 2, it would have to go above. Now here's a tricky part. If it's above the x-axis, and it's coming down this asymptote from the bottom, it would hit this one and it would be forced down, which would force it to cross the x-axis. And we know it can't go up because the only place it crosses is that one point. So this last portion of the graph has to land in this top right-hand corner. There's no other place for it. So if I start sketching in my graph in these locations, it has to hit this point. It has to stay above the x-axis. It has to approach that horizontal asymptote without touching it. So you get this little portion that looks like this. And this portion, it has to come below the x-axis. It also has to get really, really close to that vertical asymptote. It'll get closer and closer and never touch and just shoot down it in this direction. In this portion from 1/2 through these 3 points, there's no option of turning around and going down because it can't cross the x-axis. It has to stay positive. So the only option it has is to go in this direction. On the other side of 1/2, it has to stay below and get squeezed by that vertical asymptote. And then you get, the graph has to be in this location. So the only place it could go, approaching both asymptotes, would be there. And that's how you would piece all of it together, including this above, below the x-axis, and also locations of where it might cross these x-axis and horizontal asymptotes. Now the final graph, computer generated, would look like that. And this is with all the information. And this is a computer generated picture, so it's a little bit more precise than my drawing, but mine's pretty close. And that's it.